Thank you very much for the introduction. I'm Frans Peter. Take your time. From Mitutoyo. And we want to, if the laptops are switched, we want to show you the benefits of PMI. And to explain you a little bit, what I find personally most important is that from CAT, computer-aided design, CAM, computer-aided manufacturing, and CAI, computer-aided inspection. In the spiller, everybody knows how it works. But in the real smart industry, and also that's why I like so the KSA so much, Knowledge Sharing Center, the initiative of is that here the worlds come together. And if we as metrology people understand a little bit more from the manufacturing side, and we understand a little bit more from design, then we have the real benefits, and then we have winning combination. So PMI, yeah, of course, a nice product, as well, made by DMK. We're always lost in the chain as metrology people. So my biggest worry, because precision fair was the deadline, my biggest worry was normally your raw material is too late, production is lagging behind, and we have to measure it yesterday, today, that year. And thanks to DMK Mori, they did really a great job by delivering the product in time, so I had a little bit more time to prepare. What I want to show to you is introduction, small introduction for Mitutoyo, then high-tech dummy frame. Very important, in my opinion, is the third, CAD coordinate system versus product coordinate system. And maybe points for improvement for future sessions. And of course, automatic dummy frame. We have a new building.
First thing I want to do is try to trim what's left of this journal here. I left this one oversized.
Belgium and
we're going to use that CNG.
And we have open house. So if you're
try to true it up without the steady rest being run on there, so that we can have a nice.
Have an invitation. I think most people know us from calipers and coordinate measuring machines. So I want to do a small introduction movie by showing you that we have a very wide product range.
High accuracy and high quality. Evolving alongside advances in manufacturing. Mitutoyo's quality. From the very beginning, our motto has always been, quality first. Excellent quality has been achieved through our fully integrated manufacturing system, which covers everything from developing and manufacturing parts to assembly and completion as finished products. This is enabled by some of the world's leading R&D centers and dedicated plants. At the top of our traceability chain, we have developed an optical frequency comb of national standard grade. Also, our gauge blocks are specially manufactured using high carbon, high chromium steel to deliver abrasion resistance 10 times greater than that of steel. These gauge blocks are highly renowned worldwide for their accuracy, quality, and durability as reference precision measuring instruments. Based on our advanced technical skills, these calibration instruments are provided both in Japan and overseas to deliver traceability and excellent reliability. CNC coordinate measuring machines for measuring solid objects. These machines are produced at the MC plant by processing and assembling scales, guide parts, and air bearings created and supplied by our other plants. Lenses installed as the core part of vision measuring systems are meticulously created at our Kawasaki plant through various processes such as grinding and washing by a highly skilled staff, as well as vapor deposition and assembly in a clean room. In addition, we internally manufacture key parts that can determine the system's performance. In this way, everything is done internally, from processing through to assembling the systems. contour measuring machines are processed and assembled at our Kure plant. Important components, including linear encoders, arc scales, and the constituent parts of ceramic guides, are manufactured at our plants. These parts are fed into the one-piece flow production line to assemble and produce the products. The rotor installed in the rotary table of the roundness measuring machine is also internally processed and measured. Our micrometers are now produced in Japan. All processing and assembling is conducted internally. The frame of all models are sandcast at our Gohara plant. Other small components are also cast in the same way and powder-coated at our Shiwa plant. Electric modules for digital models are produced at our Kiyohara plant. Modules equipped with our internally developed custom integrated circuit are automatically assembled. The supplied electric modules are put through various processes on our own internally developed equipment prior to assembly. The products are finally released for delivery only after passing our rigorous inspection schedule. High-quality electric modules and linear encoders for digital calipers are manufactured at our Kiyohara plant. Major parts are laser cut by a laser fusion cutting machine. The processes from laser marking to inspecting scale marks are fully automated. To inspect scale marks, we use our CNC vision measuring system. Dial gauges are processed and assembled at our Nakatsugawa plant. We produce no less than 350 models, ranging from standard models to specialized models with unique features. Within the plant, we press the base plate, mold the resin parts, conduct gear hobbing, spindle processing, and pinion cutting, process, wash, and dry the housing, and paint it using robots. For software development, there is global cooperation between our bases in Japan, Germany, and the United States. Our staff on section lines take responsibility for the delicate parts and are self-driven to deliver excellent measurement accuracy. Problems they find are shared with their colleagues for discussion in order to improve quality. This uncompromising attitude to improvement is key to Mitutoyo's quality and drives innovation across our many manufacturing sites. With our commitment, pride, and advanced technologies, we are evolving to go above and beyond measurement. Mitutoyo's quality. Go above and beyond measurement.
So for the complete product range this time, we want to focus on CMM for the product. I've got to see that the presentation comes back. So we had the dummy frame, and at ASML PMI was attached to the dummy frame. So this is CMM software. This is called MICAT Planner. And with MICAT Planner, we can use the PMI to automatically generate a CMM program. And on the left side, everything is shown from the CAD model. So here you see reference A, plane. Then in the middle, the measuring instrument and CAD model come together, and on the right you will have your measurement program. What I want to do now is to focus on the references, like A, B, and C, because at ASML, luckily, they do a good job because they always use GD&T. But if we go to schools, and then we see a lot of drawings with only linear dimensions. And that's why in this metrology Bible, our metrology handbook, chapter 2 is dedicated to GD&T, because in a sustainable society, we should do everything with GD&T, or in Dutch vorm- en plaatstoleranties. And this on our schooling system is missing. That's why I want to focus on this one, because your ABC will give you your 0 point. And if we do not have GD&T, we also do not have a 0 point. And in the end, we will get such kind of discussion about products. So this is our reference plane A, combined zone. And in this case, you see a form tolerance on your A, flatness of 0.5 millimeters. This is always what you want. So form tolerances on your references, because they determine how accurate your 0 point will be. And I think that for reference B, there's no form tolerance in the GD&T. So I think it's coming from the GSA. And I think if we want to automate, then we could have a point for improvement. And this is the same for C. So also in C, we have the reference, but no form tolerances on the C plane. So this is nice about coming together in this stage and sharing this kind of knowledge to see what can we already do and where can we make improvements for future versions. And this is also an important point. The engineer will most of the time put a CAD coordinate system somewhere which we as metrology people cannot use. So the first step, what I will do, is transform your ABC to a product coordinate system. So your references, ABC, will lead to my product coordinate system, and the other one is your CAD coordinate system. And from that one, I get my 0 point, and I will compare all important things from your CAD design model with the machine, measuring machine, compared to what your question was. We were talking about radii, also DMG Mori. They say it's challenging if the radius becomes too small. By only putting a radius on a drawing, from a metrology perspective, can also be very challenging. So I think it's also good to have one special meeting about radii, how to put on drawing and how to make them unambiguous to check and to measure, because it can really be challenging. You saw blue PMI, and here you see green PMI. Blue PMI will be used to automatically generate our measurement program. Green PMI is graphical PMI. So in this case, it will not be used to generate automatically a measurement program. Why not in this case? Because to measure medical thread completely with CMM is not possible. So there I think also we can have discussions about what can we do with the CMM for thread. We can measure the position of the thread, but not the thread itself. So here we can also make maybe future steps. And another one is roughness. So here you can see an example. We can do the position by the thread, but then we should use a big sphere for probing, so that we can move with the thread and then we get good position. If the sphere is too small, we will get an issue. Roughness, I will show we can measure with CMM, but these are old roughness symbols. So also important, I think, for next step is we can also not do it automatically. Also with the current version of MICAT planner, this is 1.11. And every time we further develop to version 1.12, 1.13. In this case, we can measure roughness with CMM, but it's not part of MICAT planner. So also with discussion maybe afterwards during the drink, we can see, could it be beneficial to also measure roughness by CMM? So in this case, you have CMM, and now the probe is exchanged. So the stylus probe is exchanged by a roughness probe. And it can be done on the CMM, but it's not supported yet by MICAT planner. But I think most important is also the roughness symbols. How should we do to go from green PMI to blue PMI? In this case, the CMM is only a robot, because your probe, smallest ruby sphere we use, is normally 0.3 millimeters. For special cases, we can deliver 0.2 millimeters radius. But if you want to measure roughness, your 0.2 millimeter radius is too big. It cannot go into the material. So if you also want to do contour, you go from CMM to a contour measuring instrument, because there your radius is 25 microns. If you want to go deeper in roughness, your radius will become 2 microns. So in this case, the roughness standard radius for the measurement is 2 microns. The CMM is only used to do the positioning of the roughness tester. Yeah. Another one, this was nice, because the first presentation said already about the dimensioning and tolerance things. We should put also the tolerances on the product. These remain red because we have tolerance field of 0, 0. And if there's no tolerance, we will not measure it. So then it will be remain red. Now, I don't know how we are in the timing schedule, because yes, sufficient time, because it's quite a long movie. Otherwise, I will stop it more early, that we can go for drinks more early. This is depending on what you want. I will start the movie clip. The points that were what I discussed about is all in the movie. And this gives you an overview of how the process for automatic measurement works. Most important is to have in the virtual world everything that's also there in practice. So my fixture is also first made, because I want to have my fixture also in the virtual world, because what's not in the virtual world, I can have issues in reality by collisions. Yeah. So it's also another way of working if you start to work with PMI. You have to do in the virtual world everything already very good. This is already too early, but if you have questions, please ask them now, because if the movie starts, then I think it will be busy until our drinks. Do you have any questions yet? Yes? Yes.
We save it, but often we get feedback from suppliers that they want to save it with a certain background color. Is that also the case when you received data with PMI?
No, to be honest, I never get a question about background colors in that respect. Yeah, maybe it has to do something with the GT format. I don't know. Because normally if I use the PMI models, I always use the native format. And this is also a bit, this can be tricky for our customers, because normally they want to work with step format, because some of their customers use Siemens, others use Creo, others SolidWorks, and then they go to the step format. But we also have CAD converters that our customers can read native files in our CMM software. But then the customer, so step they will get for free. But if they want to read native format, they can buy a CAD converter for our software. And then they don't have to make the switch to step.
Do you also prefer a certain type of steps?
Yeah, if you want to contain PMI, 242. Otherwise, no PMI there. Yeah. So at least 242. Yeah. Other questions? Yes.
It's a practical question regarding the profile probe that you can measure the roughness. Can you also measure a vertical wall or inclined surface with that probe?
No, with that probe you only measure roughness. Normally you do everything with a CMM stylus with a ruby sphere. So what you here see in the movie, this is the normal way of measurement. If you want to make the transition to roughness, it's more or less becoming another field, and there we can have discussions together of what do you want and how can it be done. Because in our experience, normal drawings only contain RA values. And RA values are general roughness. If we measure roughness, we have the complete profile. So we always advise engineers, please add extra parameters like RT or other parameters that have functional-wise something to say. Because cleanliness is something for you at ASML, very important. With general roughness, you do not know anything about the peaks. So please add an RT value that you also get information about the peak value distribution.
But my question is more specifically, because you want to, with that probe, you want to measure on machine, but can you also, with that, you can measure vertical wall? Because I can imagine it's gravity that you...
No, with that probe I already showed, you can only measure roughness.
You can only, because it's always pointing down, so you can only...
No, you can, using the indexable probe, you can measure roughness everywhere you want, but it is roughness.
My question.
Yeah.
Okay.
Yeah.
Thanks.
Yeah. So normally we always prefer a CMM because it has 3 coordinates, X, Y, Z. with an indexable head, because you get 2 degrees of freedom. So if DMG Mori sells a 5-axis machine, our customer needs a CMM with an indexable head, because he also wants the 5 degrees of freedom. Yeah. Yes. Then we'll start the movie, and if I think, okay, everybody has seen it, we go for the drink. So this is preparing the fixture in the virtual environment. Now here you have the combination between fixture, product and the machine that I will use. And then on top you work from the left to the right. And then if after the machine, the blue arrow, if I push that one on the right side, the CMM program will be generated based on the blue PMI. Again, the focus on the references. Some more measuring points. So here you have our 0 point. Because it's a reference, I want to have more measuring points. And now the measurement program is generated. Now on the right side you have the measurement program, and then we can of course do a complete run virtually. And then if everything is okay, then we can send the program to the measuring machine. such an indexable measuring head gives a lot of flexibility. And then this will have an impact. Made a nice product. Say you made a nice product. Yeah, and in this case, I only used one probe for the small holes on the front. I should make an L probe. So I need one time more time. I use an L probe, which are this plane. So in the first run, I didn't measure everything. It was for precision. This we can do as a can prepare MICAT. But most important also I find this world finished. We are really transition of going paper to paperless. So you see guidelines changing, everything is 0 and 1, so also play area out of everything. So this is really not finished. We are really in the transition and we have all the challenges. I think we're together. So, thank you for your attention.
Thank you, Frans Peter. Any questions still? Or there are no stupid questions.
Because you always want to decouple the final inspection from production machine, because production machine has geometrical errors. And your geometrical errors will also be in your measurement. So that's why you want to decouple always the final inspection. Otherwise, you make the same errors in your production process.
And I think not all CNC machines have this measuring opportunity. I think it's a possibility, but...
as he said, when we have an error in the CNC machine, then we have the same error during the measuring process. For us, it's a big help that we get 90% safety, that we have the right dimension, but 100% can only be given by a CMM, the evidence.
What we normally do, because we also have SPC software, where you can put all your measurement data into a database, that's called MeasureLink. And what we then see is that the metrology data from the manufacturing procedure also goes into this database. So if we get the ASCII protocol, we can put your measurement data also in the database, and then you can see the metrology data with also the data in the manufacturing machine, and there you can make nice or smart conclusions.
We have already a connection between the CNC machine and the CMM, so that we get a permanent update of both systems, which is the right one, and to find anywhere the middle way. But the measuring machine is absolutely the final status or statement, if right or not. Because a measuring machine is much more accurate.
Yeah, I know. Normally they always say to us, the production machine should make production. So they want to minimize metrology on the production machine because it should make products.
Yeah.
Also.
It's just to get more safety. When we talk about engine parts, the raw part costs 50,000 euro before you start machining, and that you need 100% safety, that before you take it down from the machine, that everything is in the best possible accuracy. You're welcome.
Okay, then, any more? Yeah, there are several. Let's wait, I will get the mic over there. So people online can also hear the questions.
In the beginning of the video, we saw how you programmed or generate the measuring program. Was that in real time? Or
No. I speeded up a little bit the process because this ASML PMI dummy frame model is quite intense, also for hardware. So also we need ASML to work with this kind of models in a very convenient way. So this is what speeded up. In reality, it will take much more time, and you need also a lot of internal memory.
Okay, and how many manual steps do you have to do? Because in the PMI you already select what kind of feature it is and which tolerances are in it. So is it?
It's more or less checking the PMI. So we can check the blue PMI and the green PMI. So to check why is the green PMI green, and some there are good reasons, and sometimes it can also be lacking functionality from our side. So then we will take this information to MICAT Planner 1.12 or 1.13. And this is learning by doing. So we also advise customers, please send us CAD files to check what goes wrong and what goes right. And this is really case by case practicing.
Okay.
Yeah. And in the old days, it was also like three-dimensional thinking. So a lot of engineers put for making a hole, the dimension on only the two-dimensional circle on top. And then you don't have a three-dimensional axis. And then in former, this would stay green also on our side. And then we said, okay, we should make a step that also the engineer not really puts it on a three-dimensional element. Also, MICAT Planner will understand, okay, it should become blue because this is what the engineer, and this is what we learn together. Yeah.
I also want to add some words regarding PMI. The videos, what you have seen for machining, are just single sequences of a complete video later. We made this video very quickly last week in our showroom, so that I have some material today to present you. We will make the video by the end of December, then it will be ready. And we also want to show with this dummy part the complete story about PMI. That means the application engineer will get the 3D model with the PMI information. Then we program it. Unfortunately, we are not so modern like here Mitutoyo that they can make an automatic run from the CAM side for the programming. Then we machine it. And then at the end, we will have a similar video like you together with Zeiss, because we have only Zeiss measuring machines in-house. And we also want to tell the story to all the people. We are open for PMI. And also my partners from Zeiss and from OpenMind for programming, same you, they all say we are PMI ready. But when I ask them how does it work, only 50%. And my personal feeling is, if I'm wrong, then let me know, that the language the code, what all need to read from the PMI model is not defined. We need a standard for that. And I think ASML is in a position to define a standard for their brush, because there is a big supplier network behind of you, which shall use the PMI models in future. I also know from the Precision Fair, there are customers, they use already PMI models. They open it, they make a screenshot, put it in Word, print it, and then with the text marker, they highlight all the tolerances. And this is the complete wrong way, because the resolution is bad when you make a screenshot. And I think there is a big potential to work together to define a common language, and also the basics, how to set a 0 point in the 3D model in the part. So from my side, we are open DMG Mori, and in the machine tool world, we also have certain influence on many customers. And we want to show with this video during the next open house. We have this in January. We expect roughly 6,000 visitors, so 7. We all want to tell them we are open for PMI. In principle, we have no idea, and it's new for us because PMI is more or less depending or related to the CAD/CAM programmer and to the measuring. We are in the between, and we cannot use it directly on our machine. But we use CAD/CAM systems, and of course, we also want to install CAD/CAM systems able for reading PMI models to make our life easier in future, and also to adjust ourselves to the future of ASML, what is required to their supplier to go ahead with PMI. So, Mr. Springers, maybe we can open a new project, a new group, a new, I don't know, expert team from all the parties, as I mentioned. Also here, craft education is also already very deeply involved in this case. So I think this is a question to sit together and discuss the issues and the open points and what needs to be done in future. Okay, that's it from my side regarding PMI.
Yeah, only a short thing also is you saw the shaping, and we are in direct contact with the developers of, for example, CAD/CAM systems. So the shaping is a new advantage. As machine builder, we can do it, but the challenge is also to program it related to the CAD data. So it's also very interesting and important that there will be a good collaboration between the developers of CAD/CAM systems. It can be NX, but can all be the other deliverers, because we see a lot of suppliers who have also different systems where they're working with. So yeah, we hope to show you more and more in the next few months about this kind of operations.
Yeah.
Okay, there was still another question, Erwin.
It was more about the GSA in PMI. So we use it to put less GGNT as ASML designer on the drawing. But then are we just putting the responsibility of the supplier to put the GGNT that is in the GSA on the drawing? Or is there a way to directly extract the standard GGNT from the GSA to the measuring machine? How does that work?
I think 95% of our customers more or less do not have intelligent CAD files with PMI. So in practice, I think 95 or 95% is stupid CAD files, only solid, no PMI. Then we have to do it ourselves. So in MICAT Planner, we can add PMI. Or yeah, we are more or less putting what is on the drawing back in PMI. So this could already have been done by the engineer. This is the idea of PMI model-based definition. So if it's not there, then we use our PMI to more or less put the GSA PMI into the PMI model. This is the current way of working. Yeah.
Okay. And a second question, more general. On the video, we saw that it measured point by point and then it retracts.
Yeah, but I can also do by scanning. This
okay,
is
that's possible. To stay in contact with the, because I guess you get more data this way.
Yeah, this can be done. So in this case, I only did touch trigger modus. If I put it on scanning, it will scan the problem. Yeah, no problem.
Okay.
Yeah, and this one I didn't show. What I want to test also, and I didn't have time, and maybe good to discuss with Arno, is you have your general tolerance of profile of a plane. And this I want to test with a laser scanner. So we also have laser scanner for CMM, so we can switch to roughness tester, but we can also do with laser scanner. Then you get accuracy of, I think, 300 or 400 of a millimeter, so 30, 40 micron. But for your general tolerances, this should be no problem. So then we can do more or less by point cloud, check your general tolerance, and then go into depth for your critical dimensions. But this is maybe future thing we can discuss or test. So.
Maybe one last question, then the most complex GDNT to measure is the profile one, profile of a surface, of a complex surface. Is that the most?
No, in principle, we cannot measure all GDNT. Yeah, it's more like if your bottleneck is most of the time your mechanical probe, so your Hubble sphere of at least 0.2 millimeters. So if you want to have like thread, you have to go to a contour measuring instrument, as I showed in the movie clip, and for roughness to an even smaller radius, or white light interferometry if you do not want to contact. This is also a direction you can go. And there we can see, okay, for, I think, coordinate measuring machine, okay, for 80, 85, 90% of all your measurement issues. But besides the CMM, you most of the time need additional roughness instrument or contrast or roundness tester, depending on more accurate tolerances, because CMM we can go to micron, submicron to roundness. But if you want to go to nanometers for roundness, you need a roundness tester. So this is the trade-off. No.
Okay, thank you.
You're welcome.
Okay, I think that's it. Lots of questions still and lots of things to improve. We now basically started this PMI, which we as ASML use for 4 years. At least we started 4 years ago. And by now everybody should use it, but I think that's not 100% clear. And our suppliers should have the advantage of it, but that's, as you hear, it's not also completely based. So I think there's some work to do, but if we can pull this off together, I think we can improve lots of things on manufacturing and automating manufacturing, make it what we as engineers intend to be on the drawing, that it also ends up at the manufacturing itself and at the measuring, that we at least are on the same page. So there should be a language which everybody speaks and everybody understands, so to make sure that everything is in the correct place. Because I think at the moment we think, okay, we make PMI and they have to live with it, but I think we have to make PMI in a way that they can live with it and help us on manufacturing the parts in the way we want them.
Because I have one small addition, I like the PMI because we get an unambiguous discussion about a product. And this is the biggest benefit. Everybody's talking about the same, so you're directly on the same language. And this is for only drawings with only linear dimensions. We get such kind of discussions. And also bad product, then it's scrap for 10,000 euros, and you get a fight, and they're fighting like this, because they are on a lot of wavelength. And this is nice about PMI. We have one language, we talk about the same thing. And for me, this is the language of the engineer and the product.
Oh. So yeah, the alignment needs to be made, but there are opportunities, and I think we can all profit from it. So finally, I want to thank everybody again. Peter. Walter, Bernd.
Thank you very much.
Also for you, there's some gift, and we can have a drink afterwards. It'll be coffee. Arnold didn't arrange anything because the budget didn't. It wasn't sufficient budget, like that.
It's not allowed here.
If you have any questions, we want to know with the guys here, and I think it was a nice afternoon. Hope you enjoyed it also. And let's see each other next time.